Hi students, in this lecture we are going to discuss some more problems. Let us see first one. Two simple pendulums of lengths L1 and L2 are in phase at the mean position at t equal to 0. The minimum time after which they will be again in phase is 5t by 4, and t is a time period of the shorter pendulum. Find the ratio of lengths of the two pendulums. So first focus here, what is meaning of in phase? If phase difference equal to, it is equal to 2n pi, where n equal to 1, 2, 3 and so on, then they are said to be in phase. Means 0, 2 pi, 4 pi, 6 pi and so on. If phase difference equal to, it is 2n minus 1 into pi, where n equal to 1, 2, 3 and so on. That means phase difference equal to pi, 3 pi, 5 pi and so on. Then they are said to be out of phase. Now in the problem, condition given that the minimum time after which they will be again in phase is 5t by 4. Let us assume initially phase difference was 0. Okay. Initially phase difference, it was 0. Now we have to focus after what time phase difference becomes 2 pi. Then they are again in phase. Okay. Now see first step here. Omega 1 minus omega 2 into t. That gives us phase difference, and that is equal to 2n pi. So here we take n value 1 because they're asking minimum time. Okay. Then see calculation. In the place of omega 1, writing 2 pi by t. In the place of omega 2, 2 pi by t dash into t equal to 2n pi, and take n value here 1. Okay. And the value of t given here, that is 5t by 4. Now substitute that here and simplify this. We are going to get t dash equal to 5t, it is 5t. So time period is now becoming 5 times of the shorter one. And we are knowing that time period is, it is t equal to 2 pi root of L by G. So from this, we can say L proportional to T square. That means we can write L1 by L2 is equal to T1 square, T1 square by T2 square. Right? Then we get answer is, it is L by L dash equal to 1 by 25. That means we have taken ratio of shorter pendulum to longer pendulum. Okay. See next problem. Right. Read the question. A cube of a side length is L, is placed on a horizontal surface. Its bottom face is fixed to horizontal surface. A block of mass M is placed on its top face. A force parallel to upper surface is applied to M and then withdrawn. Then its a period of small oscillations is. So first make a diagram for this one. So you can try once of your one, then you can see solution. So first making diagram here. So taking one cube and placing a block on the top surface and applying a force parallel to top surface, that is F. See, when you're applying force, now shape becomes like this. Suppose this angle, take it as a phi. Let us take it is now displaced by x. This displacement is x. Then we can write shear strain. It is shear strain that is equal to x by side length is z. Right. Now from shear modulus, we are knowing shear modulus equal to F by A by X by L. Right. From this we are getting what is F? That F equal to minus eta A by L into X. Now in the place of A, we can write L square because it is given a cube. So face area equal to L square. Right. Then we are going to get here minus eta L into X. So this is of the form minus K into X. Right. Therefore, the time period of small oscillations is 2 pi root m by eta L. So you have to focus carefully what exactly happening here. When we apply force on this one, and leave that, then this makes oscillations like this, to and fro. Okay, because question given here, a force parallel to upper face is applied to m and then withdrawn. So this is now oscillating like this. Okay, right. See next problem. Just see what is the question given. A particle is moving along x-axis and its potential energy as a function of its position coordinate is given as u naught into 2 minus cos ax, where u naught and a are positive constants. Find period of small oscillations and also find maximum possible amplitude of oscillation. Next, we have to find coordinates of mean and extreme positions. Right. First, we have to focus a period of small oscillations. So whenever you are given potential energy as a function of position, by differentiating that and taking negative of the differentiation gives restoring force, which is now conservative force. We can see here F equal to minus du by dx. This is what we have learned in work energy power. So minus u naught, derivative of 2 is a constant, derivative 0. Next one, derivative of cos ax. And derivative of cos ax is a sin ax. It is minus sin ax. So minus of minus of plus. So it becomes now minus a square into u naught into x. because condition is given small oscillations. Since ax is very small, sin ax becomes ax. That's why it is minus a square u naught x. So it is of the form minus kx. Therefore, k value a square into u naught. Therefore, time period is 2 pi root m by k. That is time period. Right. Next, we have to calculate maximum possible amplitude of oscillation. So before going to that, first get coordinates of mean and extreme positions. Okay, right. So what is the meaning of mean position? So mean position means where potential energy is minimum. Now you can see potential energy function is given u naught into 2 minus cos ax. So this value becomes minimum when cos function becomes maximum. I am repeating, this potential energy becomes minimum when cos function becomes maximum. And cos function maximum value is 1. That means it becomes maximum when ax equal to 0 or 2 pi or 4 pi and so on. Let us take now here ax equal to 0. That means x equal to 0 corresponds to mean position. Right. Next, focus for which x value potential energy becomes maximum. So potential energy becomes maximum when cos function becomes minimum. That is, when cos function becomes minus 1. So cos function minus 1 means ax value becomes, it is a pi, or you can take a 3 pi, 5 pi and so on. So take now it is a pi, then x value, it is a pi by a, right? That means position coordinate for mean position is x equal to 0, and for extreme position it is pi by a. And we are knowing that separation between mean position and extreme position is modulus of amplitude. That means pi by a is now amplitude. Okay. And next we have to get coordinates of extreme positions. So one extreme position is, I am making diagram here. It oscillates along x-axis about x equal to 0. And one extreme position is x equal to, it is a pi by a. Amplitude is pi by a. Other one is left extreme, that is x equal to minus pi by a. Therefore, coordinates of extreme positions are x equal to plus or minus pi by a. Right? See next problem. You are given spring and block applying a force, and that is given 10 Newton. Asking find the compression of the spring in the equilibrium position. So first one directly we can solve it. Equilibrium position, net force equal to 0. Right. So first one I am writing here. Okay, first read the question. Remaining what we have to get. A sharp blow by some external agent imparts a speed of 2 meters per second to the block towards left. Find the sum of the potential energy of the spring, kinetic energy of the block at this instant. Find time period of resulting simple harmonic motion. Find the amplitude. So this is a question given. So first one, what we can do here, asking compression, right? That we can write F equal to K into X naught. When applied force is balanced by spring force, then it will be in equilibrium, right? F value given 10, K value 100. That means compression is equal to, it is 10 centimeter. So first one. Second one, asking potential energy and kinetic energy at that instant. See how much it is. Potential energy U equal to half kx square. X value 0.1 meter. Okay. Half kx square, that is equal to 0.5 joule. Okay. And see what about the kinetic energy? Kinetic energy equal to half m. M is given 10. V square. V square is now, wait. I think here mass is not 10. It is 1 kg. So make a correction here. Mass is, take 1 kg. Okay. Take mass 1 kg. Then kinetic energy equal to mass 1 kg half m, that is 1, v square 2 square. So this is equal to 2 square 4 by 2, it is 2, it is a 2 joule. So if you see sum of these two, he's asking sum of these two. Sum of these two equal to 2.5 joule. This is the mechanical energy of the spring block system. Okay. Right. And see time period of resulting simple harmonic motion. So it is a directly 2 pi root m by k. M value is known and k value is known. Okay. Let us now focus. Find the amplitude. Fourth one, find amplitude. So to find amplitude, what we can do here? See here the solution part. So first we got 10 centimeter. That is compression at mean position. And you are given at mean position speed is 2 meter per second. At mean position speed means it is maximum speed, which is equal to a omega, and omega value is root of k by m. K value 100 and mass is 1 kg. Okay, so it is now 10 units. So from this we got amplitude is 20 centimeter. Okay, not meter per second. It is 20 centimeter, that is amplitude. And here also I have to make correction, 20 centimeter. Right. Now see what happens. At mean position compression 10 centimeter. Now amplitude is 20 centimeter. Therefore at left extreme compression will be, I am writing here at left extreme compression. I think already we have taken here, right? You can see here at left extreme compression is 30 centimeter, and at right extreme It is 10 elongation. Okay. I am repeating. At mean position compression 10 centimeter, amplitude is 20. That means from there block moves 20 centimeter left side. So compression becomes 30. Next, from mean position, block moves right side by 20. Therefore, elongation becomes 10. And we are knowing that at extreme position, total mechanical energy will be in the form of only potential. And see what is now potential energy at left extreme. I am making calculation here. See calculation part once. At left extreme potential energy. Potential energy at left extreme is equal to half K value 100. Compression is 30 centimeter. That means 0.3 meter whole square. This is now 4.5 joule. This is the total mechanical energy of the spring block system. Okay, right. Now see at right extreme. Right extreme potential energy equal to half K. Elongation is 0.1 meter. Okay, half K x square. This is now 0.5 joule. Okay, and if you observe carefully, mechanical energy of the spring block system is not a constant. Students, here you have to observe carefully this point. Mechanical energy of the spring block system is not constant. I will show in the diagram. See in the diagram. Mean position, total energy 2.5 joule, potential plus kinetic. Left extreme 4.5 joule. Right extreme it is 0.5 joule. If you observe from left extreme to right extreme, mechanical energy of the system is decreasing. Okay. And if you take from right extreme to left extreme, mechanical energy of the system is increasing. And see why it is like this. Okay. I will explain here. See, we are knowing that work done by external force is equal to delta K plus delta U, right? Here applied force becomes external force. When block is moving right side by applied force, work done is negative. So by external force, work done is negative means mechanical energy of the system is decreasing. I am repeating. When block is moving right side, by the applied force, work done is negative. That means for the system, mechanical energy is decreasing. That is what we have seen here, right? It is changing from 4.5 to 0.5 while moving towards right side. And while moving left side, by applied force, work done is positive. That means mechanical energy of the system is increasing. Okay. So here mechanical energy of the spring block system is not constant. It is not violating energy conservation principle. Reason is by external force work is done. Okay. See next problem. You can see here the previous question, that is question number 34. This we have taken from HCV, HC Verma. And this next question also from HCV only. See the question. A 1 kg block is executing simple harmonic motion of amplitude 0.1. Given surface is a smooth, spring constant given. A block of mass 3 kg is gently placed on it. At the instant it passes through mean position. Assuming that the two blocks move together, find the frequency and amplitude of the motion. So coming to frequency, it is a direct one. Omega equal to root of k by m, right? Omega equal to root of k by m. K value given 100 and mass initially 1 kg. That means initially omega value, I am writing here, initially omega value. So take it as omega 1 initial value. That is equal to root of k value 100, mass equal to 1, root of k by m. That is a 10, right? Omega 2 value. When this 3 kg mass placed on that, now total mass becomes 4. K value remains same, 100. Mass is 4. So it becomes now 5, right? So here 10 units, now it becomes 5 units. That means the time period is changed. Now we have to calculate what is amplitude of motion. To find this, first take momentum equation at mean position. So here we have taken LCM. LCM means law of conservation of momentum. Okay. LCM means law of conservation of momentum. You can see here just before placing 3 kg block, momentum of the system 1 into 1. Okay. It is 1 into 1 because you are given velocity. Velocity not given. We are given amplitude 0.1 and we got omega 10. Therefore, V value 1 meter per second. Right? Using that here. Momentum just before placing 3 kg block 1 into 1. That is equal to momentum after placing. Mass becomes 3 plus 1, 4 kg. Velocity becomes now, take it as, so it is equal to 4. So velocity becomes how much here? It is 0.25 meter per second. Okay. Are you getting it? This is 1 into 1, that is equal to, now mass is 4. Velocity, take it as V. So I think here by mistake, this is A1. Here A1 is not there. Okay. It is a 4 into V. So V equal to 0.25. Okay. Now here there is no A1. By mistake, it is written here. So 1 into 1 equal to 4 into V. Right. Now, kinetic energy at mean position is a half into this is mass is a 4 and this is actually 1 by 4. I have written wrong here. It is 1 by 4. I will write once again here. See equation. Writing half, mass is 4, speed is 1 by 4. Okay. Half mv square is equal to, this is converting into completely potential energy when it reaches extreme position. So I'm writing here half k value 100 a square. Now take a value, it is a1. A1 square. Okay. Now see what we get. A1 equal to half. Half gets cancelled. 1 by 16. Remaining is 1 by 4. So this is equal to A1 is equal to 5 centimeter. This is now present amplitude. So initially amplitude was 0.1 meter, means 10 centimeter. Now it is becoming half. Okay. This is a way of calculating amplitude.